Okay, response to number 13, and this is our equation, and we want to find the volume of the shape, and it's in our three-dimensional graph, so we're going to have to take the double integral. So the first thing we always want to do is get our equation into z equals form. So I want to get z by itself over here, so I'm going to subtract x and subtract y from both sides, and then I am left with z equals 2 minus x minus y. So that's your first step here, is to get it into z equals form. Our second step is we want to sketch part of our graph in the xy plane. So here's my x-axis, here's my y-axis, and we can see that it crosses the x-axis at 2 and the y-axis at 2. I'm basing this off of the three-dimensional picture that I see, and you can just look where it's crossing your x and y-axis, and basically we would have a line connecting the two, and this would be our full region. Sorry, it's so tiny. So right here, if we wanted to show the x boundaries, basically our x boundaries are 0 and 2, and then our y boundaries are y equals 2. I'm sorry, it's bounded by the line y equals 0, right here. And this line right here, if we wanted to figure out the equation of this line right here, we want it in y equals mx plus b form. So we can see that our y-intercept is 2. And we can see that our slope is down 1 and to the right 1, so we're going to have a negative 1 slope. So right here we just found the equation of this line. And this is going to be the upper y bound, and y equals 0 is our lower y bound, and then these are x bounds. So we get it into z equals form, then we graph from the xy plane and we figure out our bounds. So we're going to use these for our double integral, which is our third step here, is to set up our double integral. So you can choose either one. You can do dx and then dy on the outside, or you can do dy and then dx on the outside. It doesn't really matter, it's kind of up to you. So I did dy and I did dx on the outside, so that means dx on the outside. So out here, this integral is going to get my x bounds. So we have 0 and 2. 0 and 2. And then that means my inner integral is my y bounds. So we're going to have from 0 to negative x plus 2. And then in here, we just put our function in z equals form. So this part right here is going to go right in the middle here. So we have 2 minus x minus y integral dy. So basically, we want to do this inner integral first, and then we do the outer integral. So I'm going to do this inner integral over here on the right. So this is going to be our fourth step. We take our inner integral. So we're going to integrate, and this over here tells us what we're integrating with respect to. We're integrating with respect to y. So when we integrate, basically this 2 minus x needs to get another y term kind of multiplied in there, because remember, integration, we're always increasing the number of y's in the term. And then y, the integral of y, is always y squared over 2, so that's what's happening here. And then we have our bounds from 0 to negative x plus 2. And then we want to plug in our bounds, so we're going to do upper bound plugged in minus lower bound plugged in. And remember, we're integrating with respect to y, so we're plugging this upper bound in for y. Don't get confused with all your variables. We're plugging in for y in this case. So we have 2 minus x times negative x plus 2 minus negative x plus 2 squared over 2. And then when we plug in 0 for y, we get 0 at the end, so I'm not going to show that. I'm just going to write minus 0 over here. So then we would go through and we would distribute this. So I did that off to the side, and I got x squared minus 4x plus 4. Just for the sake of time, I'm not going to do it out, but you guys would know how to FOIL that out. And then negative x plus 2 squared, I also did that off to the side. And I got, whoops, I'm sorry, this part here is the negative x plus 2 squared, so I'm going to put that all over 2. That gets a negative out in front. And then this part FOILed out is negative 2x plus 4 plus x squared minus 2x. So sorry about that, I just switched them. So this term FOILed out is now here, and this term FOILed out is now here. Sorry about that. So if we go ahead and we kind of just rewrite this so it's a little bit neater. And here we can combine this 2x and this 2x, so we have x squared plus, minus 4x plus 4. And we basically want to try and combine these two into 1. So if we want to make this also over 2 so that we can add them with a common denominator, that means we also have to multiply our numerator by 2. So we would have, that part stays the same, and then all I'm doing is distributing this 2 into the set of parentheses. So we have 2x squared minus 8x plus 8, and it's all over 2. So basically we've just added these two fractions by creating a common denominator here. And now we can combine like terms. So we have the 2x squared minus x squared. That leaves us with an x squared. We have a negative 4x and a negative 8x. No, that should be, sorry, that should be a positive 4x too. Yikes. Sorry about that. So we have negative 8x plus 4x. So that gets us minus 4x, and then that should be a minus 4. I don't know what happened to all my signs here. I think because I wrote it in the wrong order. I'm sorry about that. These are all minus. So we have a minus 4, and then positive 8 gets us a positive 4. And that's still all over 2. And I'm just going to rewrite this so the 2 is the denominator of each term. And then if we simplify, we have this. So what we just did here in this step 4 is we solved the inner integral, and we got this solution. So now we can go ahead and put this back in here for our inner, and this is going to be step 5. So now we're going to take the outer integral from 0 to 2, x squared over 2 minus 2x plus 2 dx. So now when we integrate, we're going to integrate with respect to x. So first term, integral, we always increase our power, so it's going to be x cubed, and then over 3. This becomes an x squared over 2. This becomes a 2x, and then we have from 0 to 2. And then if we go ahead and plug in our bounds, remember we always do upper bound plugged in minus lower bound plugged in. So if we plug in our upper bound, we get 8 over 6 minus, these 2's are going to cancel, minus 4, 2 squared is 4, and then plus 4. So these go away. And if we plug in 0, we can see each term is going to go to 0. So we basically just have minus 0 or 8/6 as our final answer. So this is our volume, basically. So up here we probably should have labeled V equals. So we're all set. So the most important step is to remember to get it into Z equals form. Then sketch your line in the XY plane, and then setting up the double integral. And then from there it's just straight integration, which you guys have gone over. So you should be good, okay? Hope that helps. Good luck.